Hello, this is David Tree, Algebra 2 instructor with Florida Virtual School. We're going to look at two examples here dealing with rational exponents. This is really related to the properties of rational exponents lesson, if you saw the live lesson on that. We're going to be looking at a couple scenarios where we have what we call a power to a power. All right, so x to the power of 3/5. And that is to the power of 2/3. So you have a power to a power. When you have a power to a power, that means we are multiplying exponents. So the same rules of exponents apply. The only difference is here we're dealing with rational exponents as opposed to integer exponents. Right, so this would be x to the 3/5 times 2/3. All I'm doing is multiplying the exponents. All right. Multiplying fractions, you just multiply straight across. So 3 times 2 is 6. 5 times 3 is 15. Alright, in this case, this fraction up here is 6/15. Well, we can reduce that a bit, simplify that more. They're both divisible by 3. So we'll write that as x to the 2/5. Now, if they ask you to write that in radical form, remember, the bottom number, your denominator, is your index, and the top value is your exponent. So that would be the 5th root of x squared. Alright. The next one here, we'll do the same thing with this next one. Now, this next one, we only have one rational exponent, really. First, we start with x to the 4th, and then that's to the power of 3/5. Once again, we still have a power to a power. Okay, so same rule applies. That's going to be x to the 4th times 3/5. A lot of students like to write this 4 as a fraction, because remember, when we're multiplying fractions, we're multiplying straight across. So remember, 4 over 1, not 4 over 0. So you have to multiply straight across on both of those. You have x to the 12/5. Alright, there's nothing really we can reduce with that particular rational exponent, but we can go ahead and write that in radical form. So that would be 5th root of x to the 12th. Now, this is an interesting scenario because this can be simplified. In other words, I do have the 5th root means I would have 5 of something under the radical to pull one of them out. So something times itself 5 times. Well, what we're going to do is we're going to write x to the 12th in an equivalent form that will help us recognize what we have 5 of. In this case, we have a couple things. So 5th root. Now, instead of x to the 12th, I'm going to write x to the 5th times x to the 5th times x squared. When you get a little quicker with these, you'd probably just write it as x to the 10th times x squared. Okay? Or you get real quick at them, you'll just pull out what you need to pull out without even rewriting it. But I like to take that step to look, well, we have 5x's here and 5x's here, and then underneath the radical we'll have left an x squared. Now here's what that means. Well, I've got 1x here that I can pull out. And I've got another x here that I can pull out. Remember, these are going to be multiplied outside. Now this x squared under the radical, well, that just stays under the radical. So x times the 5th root, and then under the radical we still have that x squared. Now this portion over here, x times x, you would want to simplify that to x squared, because x times x is x squared. So we'd have x squared times the 5th root of x squared. Alright, hope this helps.